In the annals of space exploration, history has been punctuated by moments of profound achievement and game-changing innovations. One such moment occurred when SpaceX's Starship successfully launched and returned its first-stage booster back to Earth, a feat that marks a new dawn for humanity's quest to conquer Mars. This wasn't just another rocket launch. It was the realization of a vision that brings us closer than ever before to establishing human life on the Red Planet. With the successful recovery of the booster, SpaceX has not only showcased its revolutionary technology, but also made interplanetary travel more financially viable. This triumph opens the door to a future where humanity is no longer confined to Earth, but can look to Mars as our next great home. For decades, space exploration has been limited by astronomical costs, making human settlement on other planets seem like a far-off dream. But with SpaceX's Starship launch and the reusable rocket technology, we are entering an era where the exploration of Mars is no longer a distant fantasy. With this achievement, the logistical and financial barriers that have hindered interplanetary travel are being dismantled. SpaceX's vision is clear. Mars is within reach, and we now possess the technology to make life on Mars a reality. The Starship launch, a bold step toward Mars. On the day of the launch, the world watched with bated breath as SpaceX's Starship stood tall on the launch pad, a gleaming symbol of human ingenuity and ambition. Powered by Raptor engines fueled by liquid methane and oxygen, Starship roared to life, leaving Earth's surface in a burst of energy and determination. This moment wasn't just about sending another spacecraft into orbit. It was the culmination of years of hard work, driven by SpaceX's mission to make life multi-planetary. The launch was spectacular, but what truly set this event apart was the successful recovery of the first stage booster. While traditional rocket stages are discarded after use, adding enormous costs to every mission, SpaceX's innovation lies in making rockets fully reusable. The booster, after propelling Starship into space, performed a controlled descent, landing back on Earth with remarkable precision. This achievement signifies a revolution in space travel, one that will dramatically reduce the cost of future missions, making trips to Mars and beyond much more sustainable. By perfecting the art of reusability, SpaceX is creating a new paradigm in space exploration. Every successful booster recovery brings the dream of establishing colonies on Mars closer to reality. With costs significantly reduced, frequent missions to Mars, carrying settlers, supplies, and equipment, are no longer science fiction, but an inevitable step in our expansion across the stars. A new era of exploration, the journey to Mars begins. The implications of this launch extend far beyond the successful recovery of the booster. Starship represents the key to sustainable space travel, thanks to its reusable technology and massive cargo capacity. Unlike previous spacecraft designed for single-use missions, Starship is built to transport significant payloads, including the essential infrastructure needed to support human life on Mars. SpaceX envisions fleets of Starships regularly ferrying people and materials to Mars, creating the foundation for permanent human settlements. But reaching Mars is just the beginning. The real challenge lies in making the Red Planet habitable for human life. Mars presents a host of environmental challenges, chief among them being the extreme temperature fluctuations and the constant bombardment of harmful radiation. For humanity to thrive on Mars, we need to develop advanced temperature control and radiation protection systems that will allow us to create sustainable greenhouses the heart of any future Martian colony, Mars, the hostile red planet. Mars is a planet of extremes, offering an unforgiving environment that makes survival incredibly difficult without significant technological intervention. Its thin atmosphere, only about 1% the density of Earth's, provides little protection from the hazards of space. As a result, Mars is constantly exposed to dangerous cosmic radiation and solar winds that can damage cells, DNA, and any living organisms that attempt to survive on the surface. Furthermore, Mars's temperature swings wildly between day and night. Daytime temperatures can reach a relatively mild 20 degrees, 68 degrees, but when night falls, the temperatures plummet to 70 degrees, 94 degrees, or even lower. These extremes create a hostile environment where unprotected plant life cannot grow and where human infrastructure could quickly deteriorate. The combination of freezing cold and relentless radiation presents two of the most significant hurdles in our quest to make Mars a second home. To address these challenges, the greenhouses of the future must be equipped with cutting-edge technology capable of maintaining stable internal conditions that will support both human life and the growth of crops necessary for long-term sustainability on Mars. Temperature control, sustaining life on Mars. Temperature regulation is a critical factor in keeping any Martian colony alive. On Earth, we are accustomed to relatively mild temperature fluctuations, thanks to our thick atmosphere and natural climate systems. On Mars, however, the lack of atmospheric protection means the temperature can drop drastically after the sun sets. For greenhouses on Mars to function properly, they must be equipped with highly advanced temperature control systems that ensure the environment inside remains constant, regardless of the extreme conditions outside. Thermal insulation with aerogel. One of the most promising materials for maintaining a stable climate inside Martian greenhouses is aerogel, a highly efficient thermal insulator. Aerogel is lightweight, durable, and capable of trapping heat, making it the perfect solution for creating a warm, life-sustaining environment inside greenhouses while preventing the frigid Martian cold from penetrating. Energy-efficient heating and cooling systems. To further regulate the internal temperature, energy-efficient heating systems will be integrated into the greenhouse structures. These systems will capture solar energy during the day, storing it for use at night when temperatures plummet. Using renewable energy sources like solar power, we can ensure that these greenhouses remain warm, even when the outside temperature drops to dangerous levels. Thermal storage units will also be employed to release stored heat throughout the night, ensuring that plants and infrastructure are not damaged by freezing conditions. Automated climate control. These systems will be automated using a network of sensors to monitor both internal and external conditions in real time. Smart controls will adjust the heating and cooling processes to maintain the optimal environment for plant growth, allowing crops to flourish under controlled conditions despite the volatile Martian climate. Radiation protection, defending life from cosmic threats. While controlling temperature is essential, protecting life from radiation is perhaps the most critical factor in making Mars habitable. Mars's thin atmosphere and lack of a magnetic field mean that the surface is constantly bombarded by cosmic rays and solar radiation, both of which are deadly to humans and plants alike. Without sufficient protection, any long-term exposure could lead to severe health problems for humans and genetic mutations in plants. Multi-layer radiation. Shielding. One of the most effective ways to protect Martian greenhouses from radiation is through multi-layer radiation shields. These shields, made from advanced materials such as polyethylene, will line the walls of the greenhouses. Polyethylene is highly effective at absorbing radiation, particularly cosmic rays, making it an ideal material for building radiation-proof structures. Water walls for radiation absorption. Another innovative solution for radiation protection is the use of water walls. Water has been proven to absorb radiation effectively, and greenhouses on Mars could incorporate water-filled panels within their walls. These water walls would serve a dual purpose, protecting against radiation while also being part of the water recycling system, providing irrigation for the crops growing inside. Subterranean greenhouses. In addition to above-ground greenhouses, the construction of underground greenhouses is another potential solution. Building greenhouses beneath the Martian surface offers natural protection from cosmic rays, as the soil and rock above act as a barrier. These subterranean greenhouses could provide a safe environment for growing food and conducting scientific research, free from the harmful effects of radiation. The future, a self-sustaining Martian ecosystem. With SpaceX's Starship leading the way, and breakthroughs in temperature control and radiation protection, making Mars habitable, the dream of human colonies on Mars is closer than ever before. These greenhouses, with their advanced climate control systems and radiation shielding, will serve as the heart of Martian civilization. They will not only provide food and oxygen, but will also demonstrate our ability to thrive in the harshest environments. These greenhouses will operate as closed-loop ecosystems, recycling water, nutrients, and air. Plants will provide oxygen, and advanced water purification systems will ensure that every drop of water is used efficiently. With automated systems controlling every aspect of the greenhouse, from temperature to radiation shielding, life on Mars will be sustained with minimal external input, a future of hope, humanity's leap beyond Earth. SpaceX's success with Starship and the advancements in greenhouse technology signal a new chapter for humanity. Mars is no longer a distant goal. It is within our reach. The first human colonies on Mars will not just survive, they will thrive, thanks to the ingenuity and determination of countless scientists, engineers, and dreamers. With sustainable systems in place to manage temperature and radiation, the Red Planet will become a new home for humanity. This is the dawn of a new era. Humanity is no longer confined to Earth. We are reaching for the stars, and Mars is our first step. The challenges of temperature control and radiation protection are immense, but with Starship leading the way, the future of life on Mars looks brighter than ever. The dream of becoming a multi-planetary species is no longer a dream. It's happening, and we are all part of this incredible journey.